Hello, welcome to my class. This class is for class 9 and in this video we are going to discuss question number 1, 2, 3, 4 from exercise 8.2 from the chapter quadrilaterals. Okay, and if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. If you have any doubts, you can ask that as comments. If you want any questions or some classes as videos, I can upload that also. So let us start now. And the question is, ABCD is a quadrilateral in which P, Q, R and S are the midpoints of the sides AB, BC, CD and DA. AC is a diagonal. Show that SR is parallel to AC and SR is equal to half of AC. So, we have to prove that this SR is parallel to AC and SR is equal to half of AC. So, take triangle, first one. Take triangle ADC. We are given that S and R are the midpoints of AD and DC. S and R are the midpoints of AD and DC. So, by midpoint theorem, SR is parallel to AC and SR is equal to half of AC. So, we can write the reason here as midpoint theorem. Okay. So, we got that SR is equal to half of AC and SR is parallel to AC. So, this part is proved. Okay. Now, second part, we have to prove that PQ is equal to SR. Here, we can take triangle ABC. Taking triangle ABC, P and Q are the midpoints of AB and BC. It is given. So, by midpoint theorem, we can say that PQ is equal to half of AC and PQ is parallel to AC by midpoint theorem. But we can write PQ equal to half of AC here. So, by midpoint theorem. Okay. Which means here, this is 1. We can write this as 1. This equation, let this be 1 and let this equation be 2. Okay. In the first equation, SR is equal to half of AC and in the second equation, PQ equal to half of AC. Which means SR is equal to half of AC, that which is same as this PQ, right? So, we can say SR is equal to PQ from equation 1 and 2. So, we have proved the second part also, that is SR is equal to PQ or PQ is equal to SR. Okay. So, we have proved the second part. You can note this down if you want. You can pause the video and note this down. Okay. Now, we will prove the third part. We have to prove that this PQRS is a parallelogram. And from this 1 and 2. So, we are proving the third part. Okay. From 1 and 2, we have PQ equal to SR and PQ is parallel to SR, which means one opposite side of the quadrilateral is parallel and equal. And from that we can say that is, it means that one pair of opposite sides of quadrilateral are equal and parallel, which means this PQRS is a parallelogram, which means PQRS is a parallelogram. Okay, so we have proved the third part also, that is PQRS is a parallelogram. Understood? You can note this down if you want. Just pause the video and note this down. Next question is ABCD is a rhombus and PQR and S are the midpoints of AB, BC, CD and DA respectively. This PQR and S are the midpoints. Show that the quadrilateral PQRS is a rectangle. We have to show that this is a rectangle. So first we'll prove that this is a parallelogram. PQRS is a parallelogram. So take this triangle ADB. Take triangle ADB. And in that P and S are the midpoints of this AD and AB, which means PS is equal to half of BD and PS is parallel to BD. So PS is equal to half of BD and PS is parallel to BD by midpoint theorem. Okay, now taking this triangle BCD, take triangle BCD and in that QR is equal to half of BD and QR is parallel to BD by midpoint theorem. So let's name this equation as 1 and this equation as 2. Okay. Now from 1 and 2 we have PS is equal to half of BD and QR is equal to half of BD means PS is equal to QR and PS is parallel to QR. Because PS is parallel to BD and QR is also parallel to BD. So PS is parallel to QR also. So let us name this as third equation. Okay, now if we take this triangle ADC, consider triangle ADC. So we'll get SR is equal to half of AC and SR parallel to AC and PQ is equal to half of AC and PQ is parallel to AC, which means SR is equal to PQ and SR is parallel to PQ. So, since the opposite sides are parallel and equal, we can say that this PQRS is a parallelogram. So, PQRS is a parallelogram. Opposite sides are parallel and equal. Okay. So we have proved that this PQRS is a parallelogram. Now we have to prove that all these angles are equal to 90 degree. For a rectangle, all the angles should be equal to 90 degree, right? So for that, let us take this part. That is this part. Here, let us name this as M. Okay. And these two are parallel lines because RQ is parallel to BD, and since this is a part of RQ and this is a part of BD, we can say that this RM is parallel to, let us name this as Y, OY. So these are parallel lines and this is the transversal, right? So this plus this will be equal to 180 degree because they are co-interior angles. So angle RMO is equal to 180 minus 90, which is equal to 90 degree because they are co-interior angles. So we got this angle as 90. Now we have to prove that this angle is 90. How will we prove that? Just if we consider these two as parallel lines and this as the transversal, these are co-interior angles. These two are co-interior angles, which means similarly this angle YRM is equal to 180 minus 90, which is equal to 90 degree because they are co-interior angles. So we got this angle R is equal to 90 degree, which means this angle P is equal to 90 degree, because we got that this PQRS is a parallelogram and opposite angles of a parallelogram are equal, which means angle P is also equal to 90 degrees. So angle P is equal to angle Q is equal to 90 degree, opposite angles of a parallelogram. Similarly, we can prove that this angle S is equal to 90 degree, and from that we can say that this angle Q is equal to 90 degree, which means all these angles are equal to 90 degree. So this PQRS is a rectangle. Okay, understood? You can pause the video and note this down. Next one is ABCD is a rectangle and PQR and S are the midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rhombus. We have to show that this PQRS is a rhombus. So first we can take this triangle ABD. Take triangle ABD, and here PS is parallel to BD and PS is equal to half of BD by midpoint theorem. Right? So this PS is equal to half of BD and PS is parallel to BD. Now take triangle BCD. Here QR is parallel to BD and QR is equal to half of BD. Same, that is by midpoint theorem. So we can say that PS is parallel to QR and PS is equal to QR. Okay, so PS, we got these two opposite sides as equal. Now take triangle ABC. Take triangle ABC. Here PQ is parallel to AC and PQ is equal to half of AC by midpoint theorem. So by midpoint theorem. And taking triangle ADC, we have SR is parallel to AC and SR is equal to half of AC. Same by midpoint theorem. So we got PQ is parallel to SR and PQ is equal to SR. Okay, so PQ is equal to SR and PQ parallel to SR. We got that also. But this AC and BD are equal. Since this ABCD is a rectangle, AC and BD are equal. But AC is equal to BD. So from this we can say that PQ is equal to QR is equal to RS is equal to PS, which means this PQRS is a rhombus. All the sides are equal and the opposite sides are parallel, which means this PQRS is a rhombus. Okay, understood? You can pause the video and note this down. Okay. Next question is ABCD is a trapezium in which AB is parallel to DC, BD is a diagonal and E is the midpoint of AD. E is the midpoint of AD and a line is drawn through E parallel to AB. Okay, this line is drawn through E parallel to AB. Given that E is the midpoint of AD and a line is drawn parallel to AB intersecting this BC at F. Show that F is the midpoint of BC. We have to show that this F is the midpoint of BC. So, how will we prove this? We know that this EF is parallel to AB. Given that a line is drawn through E parallel to AB, which means this EF is parallel to AB and given that this AB is parallel to DC. Okay, so all these lines are parallel. Now, take a point G here. So, taking this triangle ADB, considering triangle ADB, this E will be, this EG is parallel to AB, right? Because this EF is parallel to AB, which means this EG will be parallel to AB, right? So, by converse of midpoint theorem, we can say that this G is the midpoint of BD, right? So, G is the midpoint of BD by converse of midpoint theorem. Okay, now take this triangle BDC. Taking triangle BDC, this GF will be parallel to DC, right? Because this EF is parallel to DC, which means this GF will be parallel to DC. So, by the same converse of midpoint theorem, we can say that this F is the midpoint of G, right? Because this GF is parallel to DC, which means taking this triangle BDC, this F, if GF is parallel to DC, we know that this F will be the midpoint of DC by converse of midpoint theorem. So, we can say that F is the midpoint of DC. Hence proved. Okay. So, taking triangle BDC, GF is parallel to DC. So, by midpoint theorem, F is the midpoint of BC. Hence proved. Okay, understood? The questions 5, 6 and 7 from this exercise I will be uploading in the next video. So stay tuned, and if you have any doubts you can ask that as comments. Okay. Thank you and bye.